Yeah, I've got those set up ready to go, Tom, if you can hear me. Okay, so I can see that I've got Tom, and I've got those questions set up ready to go, Tom. But when other people come in, if you just put your name, if there's any questions that you want me to look at, I will do. Also, just let me know that you can hear me loud and clear. Cheers, Tom. So that means you can hear my phone ringing now as well. Very unprofessional. Sorry about that. So just make sure that when you come on, you pop it in the chat. And if there's any questions you wanted to go over from the Mathwatch task yesterday, I've got 2 so far. And then I've also got a few other questions just to go through. Hopefully get you guys doing it as we go. Cheers, Dan. Good to see you. Hope you're all right. Afternoon, Eric. Jack. How you doing? You okay? Hi, Jack. Still love that name. Very good. Very inventive. So if you guys want to make sure you've got like pen and paper to be able to go through a few questions. If you've got any questions, put them in the chat and I'll answer them as quickly as I can. I don't know if there's anybody else that you know who is going to get involved with the feed, but I'm going to wait probably a few more minutes just before I start. Okay, Jack, let me have a look. I'll see if I can sort out for you now. Hi, Jada. Hope you're all right. Sent you an email, Jack, so you should have something through via email with your username and password. Afternoon, Molly. Hope you're well. Got no Emily this week. Oh, there we go. Hi, Emily. Anybody else having issues with being able to hear anything? Okay, I'll give it 2 more minutes till that'll be 22 for me. Hi, Hannah. There might be a bit of a delay, but I'll get started then at 22:01. Yeah. So, okay, so I'll make it 22 now. Not sure if anybody else knows if anybody else is going to join. If you know of somebody else that's going to come on, then just let me know in the chat. I'll start going through the questions, and like I say, make sure you got pen and paper because there's a few questions for you to write out and have a go at. Hopefully, you found the MathsWatch task relatively straightforward. You've done this work predominantly last year, but there could also be some additional tasks. There's obviously going to be some additional tasks this year, and I appreciate it's been a while since you've looked at it. So, the first question I was asked to look at was question 7. And question 7 should have presented you with a screen that looked like this. And it's talking about the probability of rolling a 6 on a biased dice being 1/5. And you've got the 2 parts: complete the tree diagram and work out the probability of rolling exactly 1/6. So, first things first, what do we need to know about the sum of all probabilities? You're not going to be able to see that because it's off the page for you. So what must they equal? Sum of all probabilities must equal Pop your answer in the comment box or the chat box so I can see. Jack saying 1. Do we agree? Jada saying 1. Yeah, these are 1 as well. So some of all probabilities has got to equal 1. So you should be able to fill out the rest of the tree diagram. So that should be 4/5. And the second roll, these are what's called independent events. It doesn't matter what you've rolled before because it's just a biased dice. The probabilities are still going to be the same. So of getting a 6 on the second is still 1/5. Not a 6 would still be 4/5. Stop me if there's anything you disagree with. And then 4/5. Okay. Now I know that the question that I was asked wasn't specifically about part A, but you should have got that far. That's the tree diagram complete. It then says work out the probability of rolling exactly 1 6. It does not matter in which order you get that. So that could be 6 along that branch and then not a 6, or it could be not a 6 and then 6. So actually you've got 2 branches that you're interested in. So you're going along here and then down here, or you're going down here and then up there. That makes sense to everybody? What have we got to do with probabilities when we're going along the branches? Repeat that. What have we got to do with probabilities when we're going along the branches? Any suggestions? Pop in the chat. What have you got to do? If you're trying to work out the probability. Yeah, cheers, Jack. Got to multiply. Makes it easier. I know there's a bit of a delay, but it does make it easier if you try and put some suggestions in as quickly as possible. So for along the yellow branch, we're looking at 1/5 multiplied by 4/5. And then along the green branch here, it's 4/5 multiplied by 1/5. So here, that should have got that as being 4/25. And it's the same here because of them being independent events. It's 4/25. Now, I do wonder if some people might have just put the answer as them being 4/25. What should the answer be? Any suggestions? What do we think the answer should be? To work out the probability of rolling exactly 1/6? Yeah, 8/25. So yes, I think that's right, Jack. Oh no, it's not, Jack. No, Jack. Nugget, Jack. That one. You've just multiplied that by 4. You've made the 4/25 into a decimal. You've got to add the two decimals together. So as the other guys are saying, it's 8/25 because there's two different ways that you can get a 6, one 6 on its own, either by getting a 6 first and then not a 6, or by getting not a 6 then a 6. So it's 8/25, which would actually be 0.32. Yeah. Tom, is that helpful for you? I'll assume it was Tom, seeing as you got the answer right. So what I've then set up is I've got another question that is similar for you to have a go at. So first off, if you can complete the probability tree diagram, and then there'll be a question to follow. So just tell me what the gaps would be on this. If you want to write it out so you've got an example, just to show that you understood the first bit. What are the missing probabilities going to be? Bearing in mind this is independent events, and then there'll be a question to follow the second bit. So what are the missing probabilities? Just pop it in the chat. What do we think the missing probabilities are? Yeah, 2 over 5 and will not land on a 6. And then what about for the second throw? What about the 2 probabilities for the second throw? What would you get? Yeah, so it's just the same again, isn't it? So that's going to be 2/5. And again, because they're independent events, yeah, you need to remember that phrase. Means the probability won't change. Right, so you're going to need to keep that all written down. So I need to then put the question up on the next page. So now we need to work out the probability that dice will land on 6 on the first throw and not a 6 on the second throw. This is slightly different to the question that was on the Maths Watch because it's giving you a specific order. So it makes it slightly easier, really. So you're talking about it being 6 on the first throw and then not 6 on the second. So if we go back to the tree diagram, what we're talking about would be 6 on the first, not a 6 on the second. So we're talking about that branch. What does that mean the calculation you need to do will be in order to work out that probability? What's the calculation you're going to need to do? Yeah, Jada, multiplication. So 3 over 5 multiplied by 2 over 5. 6 over 25 in this case. Yeah, good, Hannah. Well done, Emily. Well spotted. So, as I say, slightly easier than the Maths Watch question, but still the same sort of format. If it had said at least one, hang on a minute, exactly 1 6, then you'd have to have also done that branch as well, if that was the case. But in this particular example, we shouldn't have got it. So 6 over 25. Yeah, good. Right then. So we said the answer for that was 6/25. Okay. Any questions on that moving forwards? I'm going to assume not and move on. So, question 12 yesterday, which was another one I've been asked to look at, was a bag contains 3 red and 5 green sweets. Tim takes a sweet at random and eats it. He then takes another sweet. Find the probability that Tim takes 2 red sweets. Well, the fact that the topic we're doing is tree diagrams should hopefully give you the idea that you're going to need to do tree diagrams. So, let's say that this is red. I will say that's green. For the first sweet, what's the probability that Tim takes a red? For the first sweet, what's the probability that Tim takes a red? Three-eighths. Yeah, good. There's 3 red overall, but there's 8 sweets in total. Eric, I think you've worked out the probability of getting a red for the second sweet there. So that means that for green it must be 8 5/8. Yeah, can you see that, Eric? I think 2/7 would actually be what goes here. Would you agree? Why is it that here both the numerator and the denominator have decreased? What's happening? That means that's true. Put in the chats, why is it the numerator and the denominator have decreased then? Yes, that's why so Tom and Jada have both said about that the number of sweets is decreasing. Yes, that's why the denominator has gone down. What about the numerator though? Yeah, there's one less red as well, isn't there? Okay, good. However, though, when you're looking at the bottom branch after that, so this is your first suite, I should say. And this is the second suite. You should have noticed that then still needs to add up to 1. So we've got 2/7 here, so that still has to be 5/7. So notice that's still the same numerator because there's still 5 green sweets, but there's 7 because we've eaten 1 overall. Similarly down here, we've got 5/8 for green. If we've had a green, that'll go down to 4/7. The red stays as a 3, but the denominator still goes down to 7, so it's 3/7. Quick bit of feedback. Everybody happy with that? Filling out the tree diagrams is the bit that's relatively straightforward. Agreed? Thanks, Hannah. Glad somebody's listening to me. Good. Okay. So for this question, thanks, Jada. The second part of this question is not there. Where's it gone? Isn't there a second part? Did I put it on the same page? Oh, I must have put it onto a different bit. No, that's not right. June tennis match is cancelled. That's no good. Oh dear, where's that other bit gone? Bear with me a second. Oh, the question. You're going to laugh at me now, because the question's right there. Yeah, the question's right there. So, by the probability that you take 2 red sweets, we're just going along the branch. So 3/8 multiplied by 2/7. That's because these are called dependent events. Because the probability of the first affects the probability of the second. Okay? So that's 3/8 multiplied by 2/7. 6/56. Now, with probability, you don't have to simplify. So it'd be perfectly acceptable to just say that that's 5/56. Unless it specifically asks for the question in its simplest form, which would get us to 3/28. Do we agree? Put it in the chat. Yes, no. Any questions? Cheers, Jada. Thanks, Tom. Emily, yeah. Hannah, good. Jack. Jack as well, good. It shouldn't be anything wildly different. Good, cheers, Dan. So what I'd like to have a go at then is, here's a wordy question. You might not necessarily need to draw out a tree diagram, but what I would like to see is what would the tree diagram look like. So here's a tree diagram. For this question. So Lily and Anna take a test. So then I'd like you to be thinking about writing something out like this. Lily, this is Anna. So probability Lily passes is 0.6. Not pass, fail. Anna pass. Not pass. Pass. So you're given in this case probably they're going to pass. So then you should be able to fill out the missing values once you've worked it out, or if you can spot it straight away, just let me know in the chat. What are the missing values? Jade is saying 0.4, 0.2. Tom agrees. So 0.4, 0.2. And then here it will just be a duplicate of the one above. Jack agrees with those above as well, so good. So we've got that. The question then is asking that both girls fail the test. So which branch am I interested in and what's the calculation we need to do? What's the calculation we need to do? Pop in the chat. Yeah, so we're looking at that bottom branch. 0.4 multiplied by 0.2 equals 0.08. Where you just got to be careful is if it's saying what's the probability that one girl fails the test or at least one girl. That's where you got to start. Be careful because you might need to add 2 or 3 of these up. In this case, it's fine because it just says both of them fail. But if it said probability of one passing, then you'd have to work out this middle branch and this middle branch. If it said the probability of at least one passing, you'd have to do the top one and the 2 middles. Or is there another way you could work that out? So let me write the question down. If you were asked about the probability of at least one pass, you could do all 3. So you could do 0.6 multiplied by 0.8, 0.6 multiplied by 0.2, 0.4 multiplied by 0.8. But is there a better way? Is there a better way to do it? Or a quicker, more efficient way? Make a suggestion, pop it in the chat. Yes. Jada, Jack. Why is it we're doing 1 subtract 0.08? Why does that work? Or if somebody else can now spot it, why is it that that will work? So I can see where the 0.08 is coming from. Where's the 1 coming from? Why am I doing 1 subtract 0.08? 0.08 is the failure. Yeah, so between the two of you, Tom and Jack, you've got that. Basically, that's the probability they're both going to fail. So at least one pass will be all of the other results. And the sum of the probabilities should equal to 1. So if we do 1, subtract 0.08, that should be working. So you come out with 0.92. Agreed? Okay, so again, little question. Fill out the tree diagram, and then there's going to be a question to come after that, but I've messed up the order of it all now. So, yeah, so there you go. Fill that out first, fill the tree diagram out, then we'll do a question. One more after this, and then I'll let you go. Although I've got a couple of questions just to pose to you at the end. So that'll be the last question. So we're just doing this one about the probability it's going to rain in June. Then one more question, and then I'm just going to ask for your feedback, if you don't mind sticking around for a little bit. So what's the probability on the first two here? So what's the probability it rains, does not rain? What do I need to fill in there? So rains 0.2, does not rain 0.8. What about the match is cancelled then? Yeah, happy with that. 0.30, 0.7, 0.3 for the top one. What about for the bottom one? Do we agree with Jada? I'm assuming you do agree, Jack. You just, the way you've written it makes it look like you're saying that it's the other way around, but the match is cancelled 0.05 if it does not rain. Yeah. So you should have got that. I would always stick with the format that's in the question. So if you've got decimals, stick with decimals. I know some of you might want to convert to fractions, but usually it's better to stick. You're then told to work out a probability that on a day in June it does not rain and my tennis match is cancelled. So again, relatively straightforward. So again, does not rain, but the match is cancelled. So does not rain, but the match is cancelled. So we're going down here, up here, 0.8 multiplied by 0.05. What are we getting there? Zero point zero 0.04. The way I always like to do those just to check is, well, I'll make one of them into an integer. We can make both of them into an integer actually. Make it 8 multiplied by 5, which I know is 40. But to make that into 0.8, I've got to divide by 10. So 10 there. And to make that into 0.05, I've got to divide by 100. Yuck. So in total, I'm dividing by 1,000. So I've got to divide that by my answer by 1,000. 0.04. Tell me. Oh, that'd be 40. Yeah, there we go. So that's divided by 1,000. Okay. Right, last one then. And then I'll post some questions to you. So you got machine A and machine B make bottles. The probability that bottle made by machine A is faulty is 0.02. The probability that a bottle made by machine B is faulty is 0.05. Shazia takes a random one bottle made by machine A and one bottle made by machine B. What's the probability that at least one of these bottles is faulty? So again, sticking with the theme, we're trying to do tree diagrams. So I'm just going to make the question a bit smaller. Pop it up out of the way. I've got something there. And I could do my tree diagram. Oh, I still managed to run out of space. Only me, eh? So that's machine A. That's machine B. So we'll say not faulty, faulty, not faulty, faulty, not faulty, faulty. First off, are these independent or dependent events? Independent or dependent? Yeah, independent events, Jack. Good. So then we've got to fill out the probabilities. Hopefully you're doing this yourselves. Probably already done it. So machine A, not faulty, 0.98. Faulty, 0.2, 0.02, sorry. Machine B, not faulty, 0.95. Faulty, 0.05. Not faulty, 0.95. Faulty, 0.05. Now it says work out the probability that at least one of these bottles is faulty. What's the quickest way of doing it? What's the quickest way of answering this question? Pop your suggestions in the chat. What's the quickest way of answering this? We have talked about it already today. What would be the quickest way to do this? So how do you say work out the fail rate and then subtract it from 1? This time we are actually trying to look at whether probably at least one of them is faulty though. So you've got the right sort of method, but what should you be looking to do? What's the calculation? So a few people have mentioned 0.931. Where's that coming from? So, Jada, just to answer your question, while people think about what's the 0.93, where that 0.931, where that's coming from, the difference between independent and dependent events is independent events, the probability is not affected. So, but like by anything that happens before it. So the probability of one of these bottles being faulty isn't affected by the probability that the one before it was, or one from machine A does not affect the probability from machine B. So that they are independent. A dependent result would be something like with the sweets one we did earlier. Once you've taken a sweet away, the probability is changing because you've taken a red sweet or a green sweet. Does that answer your question? So I'm just wondering, before I move on, where's the 0.931 coming from? And I'm waiting for Jada to tell me whether that answered the question or not. Yeah, it did. Okay. Right, I'm just going to crack on because I don't want to keep everybody too long. So the 9.31 should be coming from 0.98 multiplied by 0.95. Is that right? Is that where people were getting that from? And that's the only one where there's no faulty bottles. So then we can do 1 subtract 0.931, which will equal 0.069, which Tom had already said. Okay. I haven't got any more questions, I don't think. Is there anything anybody else wanted to ask me about tree diagrams? Anything we found difficult? Right, before everybody starts shooting off, I just wanted to ask, because last week I think we had about 20 people. We've got about 10 this week. So first off, and pop it in the chat. Are we still is this useful, or are you happy with just me doing the videos and you watching them whenever? If this is useful, would there be a better time of day? Would you prefer me to do it earlier, later? And then finally, is there a way of me giving you feedback on some of the work that you're doing that would be better than just doing these lives? So you can put an answer to any of those questions in the chat. Thanks, Hannah. Okay. Has Evie disappeared today? Okay. Well, what I'm going to do is I'm going to send out an email to all of you asking for a bit of feedback. Whether you found it useful, how I could improve it, anything else you'd like me to do that you would like to go over, any particular topics or anything like that. And what I'd also like, if the guys, those of you who are here, if you could speak to people who weren't here, who might watch it at another time, I'd really like to get loads of us here all in one go. So I say it was about 20 last week, apparently. So if we could get it to that sort of level, so like I'd be expecting people like Ferg to be around, Tom Banks. You know, there's a fair few people I'd expect to be here. I know that Georgie's been on before and Alice, but I want most people here because I want it to be beneficial. That being said, if one of you is saying this is useful, I'll keep doing it until such a time that hopefully we're back in school, but don't want to risk that at the moment. So thank you again for your hard work. Hope you're all well and your families are all okay as well. Any questions? I'll stay on for 2 more minutes, but you guys can go now. Thanks for your hard work, and there'll be another task up ready for tomorrow. We'll be on the next topic, not the next unit, just the next topic within the unit. All right, take care, guys. Nice to type to you. Oh yeah, don't forget to like the video as well. Makes me feel good.